Welcome to Chapter 4-4. We are now going to learn how to name ionic compounds with polyatomic ions. So we've already gone through how to name ionic compounds that include our representative metals, group 1, 2, and 3, also with our transition metals that are not representative. And now we're going to look at polyatomic ions. Okay, and so much of it is still the same. Okay, but it's just a little bit different, mainly in how we end the end of the name. First, you're going to identify the cation and the polyatomic ion. Okay, so your cation is going to be your metal, your anion is your polyatomic ion. And then you're going to name the cation using a Roman numeral only if you need it, only if you have a compound that is not a representative, or you have a metal, that's not representative. Okay, then you're going to name the polyatomic ion, ending with IT or ATE, whatever is present in your, whatever it shows up as in the polyatomic ion chart. And then you're just going to write the name, cation first, and then the polyatomic ion second. First, we want to recognize what metal we are dealing with. So do we have a representative metal, group 1, 2, or 3, or do we have a transition metal? In the first compound, ionic compound, we have calcium and we have a polyatomic ion. Okay, and so we know that if we have a group 1, 2, or 3 metal, we do not need Roman numerals. Okay, and calcium is in group 2. Okay, so this is where we get the calcium 2+. We know that nitrate has a -1 charge. This comes from our polyatomic ion chart. Okay, and all we have to do here is just name the metal, or the cation first, and then name the polyatomic ion, and then we just put it together. So the key here is we have no Roman numeral. A lot of students will want to add a Roman numeral in there. Okay, but we don't need it because it's understood that calcium always forms a +2 ionic charge. Okay, so we just name it as is, calcium nitrate. Okay, and we do not end NIDE when dealing with the polyatomic ion. You just name it as it is on the table or the chart that you're given. Okay. Next we have iron. Okay, we have Fe, so we know that we have to go to our table and we know that this is iron. Okay, it is a transition metal, and so that means that we're going to have a Roman numeral. We're going to have to put the oxidation state or the ionic charge in the Roman numeral, or in the parentheses. And we can find PO4 on the polyatomic ion chart. This is where you want to recognize the polyatomic ions. Even though I'm giving you the chart, you have to recognize that we have phosphate. So if you find this on the chart, you see that it's phosphate. Okay, and so what we've got to do here is we've got to find the ionic charge. So this goes back to the previous videos. We've got Fe, we don't know what this is yet. I'm just going ahead and give the answer because it's up there. Okay, so we have Fe and we don't know. And then we have minus. Okay, where did this charge come from? Where did 3 minus that charge come from on phosphate? Okay, it comes from your chart, so that you have to write not just the name. When you're determining charge, you've got to write, or not just the formula, you've got to write the charge as well. So the 3 minus charge, and we only have 1, so we have 1 phosphate, and we know this has to equal 0. And we have 1 iron, so X is going to have to be +3. +3 minus 3 equals 0. This is where we get Roman numeral 3. Okay, so the best way to understand this is just to keep practicing. So it's the same idea as before, it's just a little bit different. We've got IDE that we're ending with. We've got to use our polyatomic ion chart. Okay, so let's go from here. We've got magnesium and A and B. We know that it's a group 2A metal, so it's representative, so we do not need a Roman numeral. We know that magnesium always forms a +2 charge because it wants to lose 2 electrons to be like the nearest noble gas. Okay, our polyatomic ion is SO3. Okay, and so we're going to go to our chart where we have SO3 and we're going to find it. And we see that SO3 has a 2- charge and is known as sulfite. Okay, so we know that Mg is magnesium. You would look on your periodic table to find this. And then we have the SO3 2-, and so we see why we only have 1 atom of each, because our charges already cancel, so this explains our formula. And so because we have no Roman numeral, all we would write is magnesium sulfite. Okay, for B, we've got magnesium, but this time we have sulfate. So we have SO4 2-. Okay, once again, it explains why we only have one cation and 1 polyatomic ion, because our charges cancel. This gives us our formula, our 1-to-1 ratio. If you want to, if this helps, you can put it in parentheses and put a 1 around it, because you only have 1 of the total polyatomic ion. Okay? So now we know we'd have no Roman numeral again because we have magnesium. It's in group 2A. So we would say magnesium sulfate. Okay, for C we have calcium, which is also a group 2A metal, so we're not going to need a Roman numeral. And then we have ClO3. Okay, so we need to go find this on our polyatomic ion chart. Okay, so when you go down, you'll see that you have ClO3-, so it's got a negative charge. It's known as chlorate. Okay, we don't have to find the oxidation state or ionic charge here at all, but just to see where we got the formula from, we see here that we're going to need 2 of our chlorate polyatomic ions for every 1. That's where we got our formula from. So we now have calcium chlorate. And now we're going to do a few with transition metals, where we have to include, so we must include the Roman numeral that is equal to the ionic charge. Okay, so for our A here, if we're naming this, we would have iron. Okay, we would look on our periodic table. Fe stands for iron. We're going to have a Roman numeral, so we have to solve for this. And then we're going to find SO4 on our polyatomic ion chart, and this corresponds to sulfate. Okay. But we also need to write out the ions here, because we've got to solve for this Roman numeral. So when we've been doing that before just for practice. But here, we don't know what our ionic charge is, but we know that sulfate is 2-. How do we know this? It's in our chart that will be given to us on page 138. Okay? But now we need to see we've got 3, so we have 3 sulfates. So we have 3 times -2, and this all has to equal 0. And we have 2 times X that has to equal 0. So it looks to me that the only way that we can cancel is we have a -6 here, so we're going to have 2 times 3 to give us a +6. So our Roman numeral has to be 3. Sorry, that 3 doesn't look too good, but that's the Roman numeral 3. Okay. Now we have our barium. Okay, so I want you to think about barium. Okay, are we going to have to use the Roman numeral, or are we not going to? So I kind of feel like I might have tricked you here saying that we have to include Roman numerals. Okay, but if we find barium, it is a representative metal, so barium is in group 2. Okay, and so we do not have to come up with the ionic charge. Okay, so we can write out barium, and we find PO3 on our polyatomic ion chart, and that becomes, looks like it would be phosphite. Okay, and so we do not have to include a Roman numeral. So may have tricked you there for a second, but it is representative, so no Roman numeral, just write the name and end in with the polyatomic ion as it is on the chart. Okay, for lead, this is has variable charge. Okay, so on our transition metals, also including tin, antimony, lead, and bismuth, these we have a variable charge. So we would say we've got lead, and we don't know our charge. And if you look on your polyatomic ion list, you have carbonate. Okay, so if you go down and you find it, you should have carbonate, and it has a -2 charge, and for our lead, we do not know. Okay, we only have 1 of each, so we have understood 1, and remember, if you want to, you can put a 1 around this whole ion. Okay, do not use 3. Okay, it's 1 total of the total polyatomic ion. Okay, so if we have 1 of each, so we have 1 times -2, everything has to equal 0. We have 1 times x. So in order for us to get 0, we're going to have a 2. So x has got to equal 2. So we would have lead 2 carbonate. So for A and C, we had to find the Roman numeral, or find the ionic charge. And for B, we did not. We just had to write it out because it's understood that barium is going to always form a +2 charge because it is in group 2. It's a representative element.